Hello, welcome back to Quantitative Reasoning Online. You should have just finished the tutorial a little bit ago, and suppose now you're ready to go for the questions. So with no further ado or fanfare, let's look at question 1 through 4 of Can You Hear Me Now? Come on. Maybe. Here we go. So let's see. Here we are doing the money, British pound and English American dollars. Just remember, basically this says 7.7 pounds per every dollar. Of course, A is in dollars, which would cancel, giving us the answer in pounds. Then we could do that. Okay. So let's see, we have a tourist with $4 US and he wants to exchange it into pounds. So pounds is 0.7 for every $4. So it looks like you get 2 pounds 80. 2 pounds 80. Okay. Now let's see. Again, exchange rate still pound is 0.7 American, parameter is still 0.7 the exchange rate. On these conditions, how much would an English tourist exchange 4 pounds for in the US dollars? So 4 pounds is how much American? So again, so be 4 pounds, 0.7 American. So let's divide 0.7 on both sides. And that will get us figures out later. 4 divided by 0.7. 5.71 US dollars. Correct. I'm doing that. Assign media. Okay, parameter again, same reading. Okay, on one day, the exchange rate might be 0.7. 1 pound is 0.7 American with a 0.7. These, oh, there's another one. Okay, that's what it was. Now, the next day, the exchange rate changed from 0.7 to 0.71 American is a pound. So we have $4 being exchanged back in British pounds times 4, and that should be 284 pounds. A little bit more. Not much more, but a little more. Wow. Here we go. Excellent. So the bandwidth being used up. pretty impressive. Okay, use the spreadsheet below to complete part A through E. Okay. Okay, investigate how the value of the fraction x over c changes as x changes, c stays constant. Recreate the spreadsheet given the problem statement using technology and formula C6 to populate x over c. Click and drag. Okay, so to pull up this spreadsheet, since this doesn't work with squat, we go up here where I can open in Excel. All right. And here's a fresh one. And what do we want to do? Let's enter this into cell E6. So cell E6, I'm going to want x divided by c. And remember, recall, we want to anchor that location. Then drag this down, populate the rest of it. Okay, so what's the question? What is the value of E26? E26 is 2.5 according to the spreadsheet. All right. So let's look at what x over c does is x gets larger. Okay, so as x is increasing, as x increases, 0, 50, x getting bigger, x over c is also getting bigger. 1.125 is bigger than 0, 0.25 is bigger than 0.125, 375 is bigger than 0.25, and so forth. Okay, as x is increasing, oh, this not d, here we go, x over c increases. It always increases, it never turns around. What is the value of F26? F26, okay, so we need to get this column figured out. So let's see, I want that cell equal, okay, I want x over c, I want to divide it by b, there's b. Anchor those locations. And what do we get? Ah. Yeah, that's right. Oh, I want to power. Here we go. X over c raised to the b power. The reason it wasn't right because I wasn't getting that guy there. All right, so let's pull it down. And it looks like we had 0.004096. 0.004096. Double check that. That's correct. least the type is correct. Okay. (2.5) to the minus 6. Ah, 4 decimal places. Dang, I haven't. So 4 decimal places would be 1, 2, 3, 4. So I need to round that to 0.0041. The details is in the fine print. All right. Now, what is x over c to the b doing as x gets larger? Okay, as x gets larger, it goes from really big, smaller, 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 getting smaller, more small, even smaller, going down. Okay, it doesn't decrease, increase. Oh, how serendipitous of that. So as x increases, this guy is getting smaller and smaller. All right. And if we were to extend the table to include even larger values of x, what number would the value of column F approach? Yeah, let's just go and do let's just throw 10,000 in. And he goes up, and wow, that is a 4 with 9 zeros in front of it. There are 9 zeros. Actually, 8 zeros, 0.0. That's getting mighty small. That's basically 0. 0. Alrighty. Okay. Use given place value chart to complete part A through B. What fraction form of 0.1 is? Okay, it's a fraction form, so it's 1/10, or 1 divided by 10 to the first, or 1 over 10. .01. Okay, that's 0.0 is 10 to the minus 2. 10 squared is 100. So that says take 100, put that in the denominator, so 1 over 100. .001, that's 10 to the minus 3. 10 to the third is 1,000. That negative means make that the denominator. So 1 over 1,000. Let's see, final observation from relationship, blah, blah, blah. Click on view spreadsheet. Okay. The pairs of powers of 10 are reciprocals of each other. The positive exponent results in the reciprocal rates that sign opposite negative exponent. As x grew larger, x over c got smaller, but x over c got larger. That's what I saw. Oh, actually, yeah. X over c got larger. Okay, that doesn't hold up. Not A. The pairs of powers of 10 are negative reciprocals. As x grew larger, x over c got larger, but x over c got smaller. That has possibilities. The pair of powers of 10 are equal to each other. Nope. The negative exponent results in the reciprocal raised to the sign opposite of the negative exponent. X grew larger, x over c got larger, but xc to the b got smaller. The negative exponent results in the negative reciprocal of raised. No. Negative exponent, negative reciprocal raised to the sign opposite. Wow, that's really crazy. The negative exponent results in reciprocal raised to the sign opposite of the negative exponent. A lot of gobbledygook there. And it was this negative exponent, negative reciprocal that made this guy wrong. One more. Okay, another meaty one. Finding information between A and B. That's good. In 2013, there were more than 3.4 billion people that own at least one phone. More than 90% of the people worldwide in 2010 were covered by a mobile phone signal. Wow, all those zoomies going through your tinfoil hats. There are more mobile subscriptions than phone owners. There were 1 billion subscriptions in 2000, and they were projected to be more than 6.8 billion by the end of 2013. The number of subscriptions is higher than the number of people owning phones, because many people have multiple phones or multiple SIM cards in one phone. Is that right? Due to this, they expect the number of mobile subscriptions to be higher than the world's population in 2014. Annual rate of growth starts to slow down as the market becomes overloaded, aka saturated. In 2010, the annual addition to mobile subscription peaked at 680 million. The rate of increase decreased in 2011. It was estimated 424 million new subscriptions will be added in 2013. It's about 250 million fewer than 2010. So over 600,000 were done in 2010. I think I said that somewhere. There we go, 680. So what is the projected number of mobile phone subscriptions by the end of 2013? The approximate number of mobile phone subscriptions was projected to be more than, let's see, subscriptions projected to be more than 6.8 billion by the end of 2013. So right here. Okay, read the third paragraph. That's not a paragraph, so that'd be 1, 2, 3. Which of the following statement accurately reflects the information in that paragraph? The number of new subscriptions in 2013 was fewer than the number of new subscriptions in 2010. The number of mobile phone subscriptions declined from 2010 to 2013. Now, reading the paragraph, they speak of subscriptions, not the net number of phones. So the decline was the subscription increase rate. What was increased was decreasing. So number A. And that is it. Oh my goodness. All right. So that is it for lesson 11C tutorial, preview, both the tutorial and the questions. If you haven't been doing side by side for the most part, you need to go back and do the questions 1 through 4 now on your own to get the points for it. To which point then you can go and work with Stephanie on the workbook tutorial that goes along with this preview. Copy it, PDF it, photograph it, upload it, and then work on 11C. And I will see you shortly for preview 11D of quantitative reasoning online.